and gentlemen, yes, today I'm very grateful that I've been invited by IK Academy to do a presentation of my training, a brief introduction of what I do in the practical industrial electro pneumatics for the participants. Okay, as you can see from the first slide here, we uses simulation software, which is AutoSim Premium, together with a practical electro-pneumatic experimental training kit, which was developed actually especially for this training with both the pneumatic and electro-pneumatic components. Okay. As you can see from this slide, that we have done public training at hotel in those hotel rooms, also with the training kits as well. We bring the training kit to the premise or to the venue, and then students or participants will be able to do their practical training. Most of our training are on the practical exercises, which means that later you'll be able to see what are the practical exercises that we are doing. Okay. So as you can see from here, we do both in-house as well, right? We bring the training kit as well to the venue of the customer or the client. Right, and then you can see that at the bottom left, we use a simulation circuit. At the same time, the practical electro-pneumatic training kits. So it works together and they simulate the circuit diagram simultaneously or offline. On the right-hand side, you can see the participant trying to connect the electro-pneumatics circuit diagrams. Okay, in our pneumatic automation, right, our entry level is actually 0. Right, we start from the very basic principle to the very practical techniques. Right, we start from basic principle, which are the theories, and then after that we'll do the practical exercises, and together with the circuit simulation for further and easy understanding. Okay, what are the importance of education in pneumatics? Okay, so we provide innovative, high-quality solution to our client and participant. Our training dedicated entirely to educating employees, offering continuous updating courses, including practical tools for continuous and effective learning, using the latest state-of-the-art tools for easy understanding. That's what we have shown you, the simulation software just now. Knowledge is our greatest asset. When it comes together with imagination and creativity, ideas are born, which then stimulate progress and growth. The rapid evolution of technology in industries greatly demands component manufacturers and educators in providing solutions for their industrial application. In particular, automation process within each sector, with pneumatic representing one of the most common technologies, offering adaptable and high-performance solution. Pneumatic is, as you can see from here, pneumatic technology and customized industrial solutions consist of pneumatic control technology plus the electrical control technology. Hence, it is called electro-pneumatic control technology. It's actually derived from two separate technologies combined together. Okay, so here pneumatic is one of the oldest technology discovered during the Greek Empire. As such, the word pneuma is used instead of air. So pneuma is actually a Greek word for air. Although pure pneumatic control applications are getting less in industries, however, electrical control technology can be complemented to it, can now expand its applications to cover a very much wider areas of industrial applications. Hence, electro-pneumatic control technology becomes an important part of today's industrial automation process. So here in this slide, you can see the content of the pneumatic principles, right? So this will be the beginning, the theory parts, which is very important for especially those with a beginner with zero knowledge about pneumatics. So we will start with introduction about compressed air, You can see the pneumatic actuators, types of cylinders, right? And the torque cylinders and rotary actuators in the separate format, and positioning, cushioning of the piston movement. This is also another area where a lot of people doesn't really involve into this cushioning, and thus they create a lot of a problem or challenges arise in the equipment. Control elements is also very important to control. The function is to control the air and also the cylinders, the actuators. Then we talk about the control of double acting cylinder. We also learn about how to control the flow of the air in order to control the speed of the cylinder. And also with quick exhaust valve, servo control 3-port 2-position valve, which is a new technology, not the recent new, but compared to the older version, which is using direct actuation, we use servo control. And then we have the talk about seals and during the maintenance of the pneumatic components. And also we will do the basic pneumatic circuit, understanding and comprehension, drawing of circuit and reading of the pneumatic circuits as well. So here are the topics of the practical exercises. As you can see, our exercise start from F1 and you will go all until F43. So here are some of the all the topics that we are going to do in the practical, both in simulation format and also in the practical training kit. Okay, so you learn about the logic functions, all the type of logic function using the electrical control, of course. Then with relay and without relay, right? Interlock circuit, function memory, right? We also have the delay circuit using timer, time delay on, delay off, pulse function, right? Control of single acting cylinders using pilot circuit. Pilot circuit here is the electrical pilot circuit, right? Using normally open or normally closed. So all these applications into the cylinders and double acting cylinder and single acting cylinder. The control part is the electrical, which we have done earlier during the what do you call that, the logic function, right? So you can, as we go along, we will control double acting cylinder, various type of control using 3-way valve. We can also control it unistable or monostable, in other words, or bistable, using unistable valve or bistable valve. Right, of course, the 3-way valve is used to control single acting cylinder due to its one outlet, and double acting cylinders are controlled by 5-port 2-position valve or 5-way valve. Okay, so here again we do the exercises. Automatic cycle equipped with a start-stop switching, right, whereby you can control the sequence of the flow from one cylinder, and later on we can have up to 2 cylinders. Right, as you can see on exercise 41, F41, cycle using 2 double cylinders, double acting should be double acting cylinders using 5-way unistable valve. And 42, doing the same exercise, but using 2 double acting cylinder, but this time we're using 5-way bistable valve. So which means that we can either use unistable valve is actually in electrical control valve is single solenoid valve, and the bistable valve are actually the double solenoid valve. Okay, so we can use single solenoid valve or double solenoid valve to control both 2 double acting cylinder together. Either way, because we depending on the situation and also the machine developer. So some machine developer uses unistable valve or single solenoid valve, but yet they can still control the sequence of the cylinders. And others will use bistable valve or double solenoid valve to control the similar circuit diagram. So all this will be shown and will be taught in and during the training session. And of course, the last exercise is a cycle using 2 double acting cylinder with 2 different programs. Right, meaning that you can switch over one program or the other. Right? All these exercises are using electrical control with relays only. and without not using PLC. So this will provide a gateway for those who going to learn PLC in future. If they have the basic of practical electro-pneumatics knowledge, it will be much easier for them to transfer the electrical circuit diagram into PLC electrical programming ladder diagram. Okay, so this will end our first part of the slides. I will going to show you continue the next part of it. Okay, so here will be the subject matter, just to illustrate a little bit what we do in the during our theory session. Okay, this is very important because to understand the fundamental and basic of what is pneumatic before we can do the exercises. Without this basic knowledge, it's very difficult. If it's not impossible to do the practical exercises without understanding the fundamental of pneumatics. Okay, so as we can see earlier in our content of our training, right, we have the introduction to pneumatics. So this will talk a little bit about pneumatics, right? What is the application, especially those who are already working in the industry, they should already know what is pneumatic and where does it come from. As you can see from the picture, yes, it comes from the compressor and then through the duct dryer and then all the way into the plant, right? And into the machine where you connect it to the control valve systems and the actuators as well. Okay, the origin of pneumatics was, as I mentioned earlier, the word pneuma is originated from Greek, right? And it means air or wind. So it was documented by Mr. Heron of Alexandria in the 60 CE, right? And Heron was an inventor, a mathematician, a physician, of the author of the book in mathematics, physics, and mechanics. So this is the person that without him, there will be no pneumatics until today. So here is the one who invented that air, compressed air, in other words, will be used in the control system, or rather in automation. Yeah, some application also will be shown and will be discussed during the training session, right? And sharing, if it's a public course or training, we will share different type of application from different industries, right? Such as packaging, right? Process control, etc., etc. Then we talk a little bit about compressed air, and actually we talk about air. A lot of people assume that like air is free. Yes, air is free, but however, when we talk about air here in the pneumatic, we're talking about compressed air. And compressed air is very expensive because it requires electricity to produce the compressed air from the motor of the compressor. So again, in the pneumatic systems, there are some industries use purely pneumatic systems, such as the oil and gas, chemical plant. So these are just to name a few. They will try to use as much as pneumatic as possible due to its not inflammable, not easily inflammable. So then we talk about advantages of pneumatics, which are some of the list of advantages of pneumatics, which we discussed thoroughly during the training session, and participants will voice their own other advantages to include into the list if it's not in here. But generally, we find that pneumatics, the advantages of pneumatics, of course, there are also limitations of pneumatics. But again, the advantages is very, very much more than the limitation. So since there are only limitations, they are not totally disadvantaged. It can be overcome, right? And we also will be showing how to overcome the limitations of pneumatics. So we have working units like example of where we use it, for example, for fastening things using tools, right? Pneumatic tools are very common, especially in the workshop, the automobile workshop where they will want to, what do you call that, using the air tools, the wrench, air wrench, right, with the correct torque to tighten or remove the screws of the tires. And there are basically two types. One is a linear movement for the working units of pneumatics, and the other one is a rotary movement. So linear movements, the common movement are using cylinders, as you can see from the picture there. So it comprises of single acting cylinder, double acting cylinder, and also rodless cylinder. So all the these three types of common actuators, or we call it cylinders, are used in industry, and different application and controlled by different control valves. So here also is a cut away or cross section of a typical cylinder, whereby you have how the construction of the cylinder is being built using a barrel, piston rod, piston, and then with the end rod, end cover, right? So the detail will also be illustrated why and each part of the component, and how to remove, and also to what you call assemble back after the maintenance or repair. So here we talk about the movement of the cylinder, right? The movement of the cylinder, instead of talking about cylinder moving out of the barrel, coming in or extended or retract, which does not signify whether, depending on the cylinder position, whether it's holding vertically, right, or horizontally. So we use the term like plus and minus. Okay, so we have the plus chamber, we have the minus chamber. So if you supply air into the plus chamber, the cylinder, the piston will move to the plus. So hence we have a plus movement, and eventually it will end in the plus position. If you supply compressed air into the minus chamber, on the other hand, we will move the piston to the minus position and having a minus movement, and eventually you will reach the minus position. So thus using plus and minus, these two words, we regardless of where the orientation of the cylinder, whether it's vertically mounted or horizontally mounted. Then we have the single acting cylinder. As you can see from the picture, there's a spring. It can be having a spring on the minus chamber or in the plus chamber, depending on the application. Okay. So here you see that we use a control valve here, and control valve is a 3-port 2-position valve, right? To control, because there's only one, consists of 3-port 2-position, consists of one outlet, air outlet only, which is connected to the supply inlet of the single acting cylinder. So when the valve is in the exhaust position, the spring will push the piston back to the minus position. For a double acting cylinder, there will be no spring in the cylinder chamber, right? So meaning that when the cylinder moves to the plus position, it will remain there even though the air pressure has been removed. Likewise, to move it back to the minus position, you have to supply air pressure into the minus chamber. Okay, and we also talk about the force of the cylinder, which is very important. So in theory, we also calculate force by using the formula pressure times area. The pressure is of course the working pressure, which is determined in the machine, normally about 6 bar, times the area is the area of the piston, right? The area of the piston that pushes the piston to the position, to the plus or minus position of the cylinder. This is also important because when calculating the force, we know that whether the cylinder is leaking, or whether it's have enough force, or whether it's a component failure, or is it just the pressure, because force is directly proportional with the pressure and also the area. So we can either increase the area of the cylinder if you want to increase the force of the cylinder, right? Or we can increase the pressure of the cylinder of the air, compressed air, to the same cylinder area, and we can increase the force, right? So all this will be taught during the training session, right, whereby we can do some calculation, and then we will also determine how to determine the size of the cylinder, or how to determine the working pressure of the cylinder. So here we talk about double acting cylinder, and it's controlled by a five two-way valve. 5 two-way valve have 5 ports, of course, 1 supply port, 2 exhaust port, and 2 outlet port. So since the double acting cylinder has 2 connection port, so it is important to use a 5 two-way valve so that you can control this double acting cylinder. One way when the compressed air goes into the chamber of the cylinder, and then the other side of the chamber will be exhaust through the exhaust port of the valve. Then we have a shutter cylinder, or we call it rodless cylinder, commonly called rodless cylinder, right? So it is rodless because there's no piston rod protruding out of the cylinder barrel, right? So there is a shutter, right, that moves within the length of the barrel, as you can see from the bottom picture. So basically, there are actually 2 types of rodless cylinder. One is mechanically connected, meaning that the barrel and the shutter there's no connection at all. There's no opening on the barrel, right? So the magnet in the piston will pull the shutter from one end to the other end, right? When compressed air is supplied to the port of the cylinder, okay? Hence, you find that you will move left to right, but without any connectivity between the piston and the shutter. Okay, but the disadvantage of this is that it cannot carry too heavy load, because if your load is too heavy, you find that the magnet is not strong enough. So even though the piston move from one end to the other, but the shutter will remain in the same position. The other type is the mechanically connected type. As you can see, there are what do you call that? The strip, right? Inner strip and outer strip of the shutter. As you can see, the shutter is internally connected with the to the piston, right? And then it is protected by 2 seal slip. One is the inner strip, and the other one is the outer strip. The inner strip is to prevent the air from escaping out, and the outer strip is to prevent dirt from going in, right? So in this way, you find that the piston can move from one end to the other, as the shutter is also will move from the same end to the other as well, because they are internally connected together. So it works like a zip in our pants or in our jacket. So it acts as a zip. So the function will be similar. Okay. Right here is another picture of it, right? Of the shutter or rodless cylinder. So we also have other types of cylinders, some special cylinders which make for special application. That means sometimes you have a guided cylinder, you have a 2 double rod cylinder. You can also have multi-position cylinder. Why do you need multi-position cylinder? Because remember, force is equals to pressure times area. So if you have double area here, so we mind that the force will be higher at the end. Okay. So here are some of the examples. Also for different position, right? During certain application, you need a fixed position, right? In the minus, then in the intermediate, and also in the fully extended position. So we also have tandem cylinder like this, okay. Double rod cylinder, as I mentioned earlier. So because if you do not use a rodless cylinder, or you can't use a rodless cylinder, but your piston rod is very long, you have a very long stroke of piston rod, so you find that it will not be stable if you use only one single piston rod. So therefore, it's advisable to use double piston rod. And also because of this, you have a bigger area, double the area, you will get a higher force at the output as well. Okay, then we move on. We're still in the cylinder side. We still move on to the end positioning or cushioning, right? It is end positioning cushioning. So many a time you find that the bigger cylinder, especially bigger cylinders, that they have, especially if they're moving very fast, at the end of the cylinder, you will hear a big knocking sound at the end cover. Why? Because it does not have proper end position cushioning. It will not affect the speed or the stroke, but only effective at the end of the stroke, whereby cushioning is required to prevent damaging of the end cover. Okay, so both the front and the back, you should also have end positioning cushioning. This is especially important if you have a big cylinder and have a long stroke. Okay, so this will also be taught in the training, the theory part, how and why to how to adjust the end cushioning, which is adjustable usually, right? Especially for large cylinder with long stroke. Okay. So this is the air cushioning, how it works. Okay. Then after the cylinder section, we move on to the control valve, okay, which is actually much more important compared to the cylinder, because you're controlling the cylinder. Control valve are used to control the cylinder movement, right? Either is controlling the movement in the pressure, right, direction, or flow. So here are some of the control valve. It's a solenoid valve or electrically controlled valve mounted nicely in a bank, right? So in control valve, there are different types of valve. We have the manual valve, okay, and we have the mechanical valve. Manual valve are valve that we use like push button, right? Valve, right? Using what do you call that? A switch valve. All these are manual valve that we use our hand, as you can see from the picture, to control it, to turn it, to actuate it. Whereas the mechanical valve can be used, is like, for example, limit switches, limit valve, roller valve, right? All these are called mechanical valve, actuated by external force. Then we have the electrical activated valve, actually coming in from the electrical signal, usually 24-volt DC for the industries, and especially for PLC output, 24-volt to control the solenoid, turning it on and off. And also we can have pneumatically control, what do you call that, the activation control of the valve. So basically there are 4 types of actuation: manual, mechanical, electrical, and pneumatic. So in this pneumatic diagram, we can see that if it's a pure pneumatic, right? So numbering system are also, these are ISO numbering system, is also taught, right? Whereby the number in pneumatic control valves are very, very important, and it's very meaningful. Meaning that port number 1 is always a supply port. The even number 2 and 4 is always the outlet port, and 3 and 5 is always the exhaust port. And the control port is always have 2 digits, meaning that why is it 12? It's not called 12, it's called 1, 2, right? Port 1, 2, meaning that if you supply air into port 1, 2, right, the valve is open between port 1 and port 2. If you supply air pressure into control port 1, 4, it will move the spool in such a way that supply air in port number 1 will be connected to port number 4. Okay, so it's very meaningful and very easy to understand. And all this will be taught during the training as well. So I can see from here the control valve, electro pneumatics. So if you look at the symbol of the magnetic valve or electro pneumatic valve, right? So you find that there is a plunger to open up, right? Once it's open, there's a connectivity from port 1 into this solenoid valve, right? And then it will push the piston to the other direction against the spring. Okay, when it's de-energized, the spring force will push it back to the normal position. Hence, a single solenoid valve or a unistable valve will have a normal position. Then we also have pneumatic logic. Besides the electrical logic that we have seen earlier in the electro pneumatic, if we are using pure pneumatic logic, circuit diagram, there are also pneumatic logic such as AND and OR and NOT. Okay, so the AND, we're having this one is a passive connection, passive OR valve in the top diagram, you can see. So you can have two separate two-way valve, right? So the shuttle valve or the what do you call the OR valve will have only one outlet to the single acting cylinder. So by pressing either of the valve, you will find that the cylinder will also move to the plus position. Okay. In the bottom program, in the bottom picture, you're using the dual pressure and logic valve, right? So meaning that you need to press both, activate both valve in order to have a signal outlet at the end valve. Okay. So this will be the simple basic logic valve. So there are four main types of directional control valve. Right? You have directional control valve, pressure control valve, flow control valve, and the locking valve. Okay. So directional control valve, as the name implies, is very interesting that the name itself comes from the determines the function of the control valve. For example, directional control valve, the function is to use to control the direction of the cylinder. Pressure control valve is used to control the pressure, or sometimes we call it pressure regulating valve. So we can regulate the amount of pressure required. Then we have the flow control valve, right, to control the flow, right, of the air going into the cylinder or going out of the cylinder, so that we can have control the movement of the cylinder. And then of course the locking valve is just a on-off valve or shut-off valve. Okay, so we will start here with the common valve, that is the directional control valve. Okay, so a directional control valve consists of valve housing, moving valve, spool, as you can see from the picture, right? The half body and then the spool which direct the flow of the air. The design of the flow allows the air to pass through the ports of the valve, right? You can either direct the air through one of the ports or redirect it to the other. So it is also possible to totally block the air in some instances. So you can have a position whereby port number 1 is closed totally. Okay, depending on your application, then we can do a selection of type of valve. Right. So here is an example of a 5-2-way valve with the port numbers marked on it. Right. Port number 1 is, as you can see, all valves have the similar, whether regardless of any brand, is the odd number and even number are opposite each other. Okay. So in this case, there are 5 ports, right? So the even number here is on one side, and then the odd numbers on the other side, 3, 1, and 5. So 1 being the pressure supply port and the exhaust port on both sides of it, 3 and 5. So the other outlet ports are always port number 2 and port number 4. And the numbers varies from manufacturer to manufacturer, meaning that 2 and 4 can be interchanged, provided opposite 2 is always port number 3, because you exhaust the air from 2 to 3. And opposite 4 is always port number 5, because the exhaust of air from port number 4 always goes to number 5. Now here the symbols are also very important, because in order to be able to read the circuit diagram, so we have to understand and know how to draw circuit symbol. So symbols of valves are also taught, and without memorizing. There are easy ways of how to draw 3-2-way valve, normally open, normally closed, unistable, bistable, etc., etc. So all these will be exercises done in the class during the training by the participants. So after the training, participant will at least know how to draw the symbols without turning the paper. Some people just draw the symbols horizontally all the time. So sometimes you need the valve symbols to be in a vertical position. So what they do is, I have seen a lot, they turn the paper and still draw it horizontally, and then turn it back to become vertically. So after the training, I find that the participants are able to draw what they want to do at any position or any orientation. Okay, so here is another example of the circuit controlled by a 3-2-way valve with one outlet, right, one inlet and one exhaust attached to the single acting cylinder. So here are the symbols of a solenoid valve. Okay, so the inlet is always port number 1, outlet is number 2, and the R here is the exhaust or air release. So this is whenever there's a spring, so one is the normally open, one is the normally closed valve. So we were also taught to identify how to identify normally open valve and normally closed valve. Okay, so you can see from the what do you call that, the diagram or the circuit symbols, one is normally open and one is normally closed. Okay, so here's an example. Then we have the pressure control valve, right? As I mentioned earlier, after directional control valve, we have the pressure control valve, which is, we also call it the pressure regulator. Okay, so usually we have the regulator combined with the filter. So we call it the filter regulator unit. And of course, with pressure control valve, we attach a pressure gauge to it, so that we can identify, or we can know that what is the air pressure at the outlet after the pressure regulator. Then we have the flow control valve. There are two types of flow control valve. One is two-way flow control valve. Another one is the one-way, or we call it the non-return throttle valve. So it's a combination of a throttle valve and a non-return valve or check valve. Right? As you can see from the picture on the right, right? It's integrated together. Although it's two valve symbol, but it is in one unit, is integrated. Okay, so that in one way, it is it passes through the what do you call that, the throttle, the flow control valve, and it can be adjustable. On the other hand, the other direction, it pushes the ball bearing inside the valve, the check valve, and you cannot be controlled. So in one way, it acts like a throttle valve. In the other direction, it acts as it does not control the flow. Okay, the logic control valve, again, here is we talk about the logic control valve. Just now we talked about the all valve. Now you can see on the right hand side, or we call it the shuttle valve, or raw or all valve. Then the below is the end valve, or we also call it the dual input valve. Okay, on the left side you find that there are also the yes valve and the what do you call it, not valve. Okay, a yes valve is actually basically a normally closed valve, a 3-2-way normally closed valve is considered as a yes valve. But because you energize, then only what do you call that, there's an outlet, the air at the outlet. Whereas a normally open valve in the left bottom symbol, right, is called a not valve. Why? Because without actuating the solenoid or the coil, there's already outlet at the outlet port. There's also already pressure at the outlet port because it's already open. Right? So when it's energized, it's the reverse. It will be closed. Okay. So We have 4 types of logic valve here. Basic logic valve. There is the AND valve, OR valve, NOT valve, and YES valve. So in summary, we have gone through various types of valve and how they are controlled. So the most common type of valve is the directional control valve, as you can see, which redirect the airflow from the connection ports. So there are basically 2-port 2-position valve, 3-port 2-position valve, 4-port 2-position valve, which is not so common nowadays, 5-2-way valve, or the 5-port 3-position valve. Where the first digit shows the number of ports or number of connection of the valve, and the other the number of position it has. So we have also looked at other valves, and among these are flow control valves that are used to throttle the amount of airflow passing through it. So pressure regulators are used to regulate the amount of pressure needed at its outlet to maintain a constant pressure and power. Because remember, force equals to pressure times area. So if we have a reduced pressure coming into the supply, our force of the cylinder or actuator will also be reduced. If it's too high of pressure, we find that our force at the output of the actuator will also be increased. So this is very, very important. Control of valves are now most commonly achieved by using electrical signal. So other methods of controlling or actuating valves are used by using manual, mechanical, magnetic, or using compressed air. So this we have already done just now, just a summary of it. So I think this is all I have got for now during this presentation. So thank you very much for listening patiently to my presentation, and hope to see some of you in a future our training session. Thank you very much, and I'd like to pass it back to Ms. Diana.
Thank you, Mr.